In this second lesson about systems engineering, we're going to consider how systems engineering fits into the system lifecycle. Many organizations use different labels for lifecycle stages. Throughout the specialization, we have referred to Michael Greaves' breakdown of lifecycle stages. For this course, in the systems engineering perspective, we will work with the lifecycle stages defined in the 15288 standard. In the standard, a lifecycle is defined as a system progresses through its lifecycle as the result of actions performed and managed by people in organizations using processes for execution of their actions. The lifecycle stages used in the standard are concept, development, production, utilization, support, and retirement. Different models have emerged for managing the processes within and across lifecycle stages. Waterfall, published by Royce in 1970. The spiral approach, developed by Bohm in 1986. And V, developed by Forsberg and Mose in 1991. V is often equated with systems engineering, although any of the approaches can work with systems engineering practices. Something to keep in mind is that a pitfall of graphical representations of lifecycle processes is they imply a static, unidirectional flow. In reality, the processes that provide the foundation for the models are dynamic, iterative, and recursive. When considering iteration and recursion, it is easy to get pulled into a detailed discussion. For example, the CBOC has a more in-depth description of each. It is important to understand the meaning of these patterns as they're important to the implementation of systems engineering practices. Iteration means repeating one or more processes in order to improve a design by using newly available information. And recursion is applying the same processes at finer and finer levels of detail. A mental model of recursion that can be useful is nesting Russian dolls. The recursive operation would be open a doll, remove its contents. This repeats until the doll that was removed cannot be opened. A system engineering example of a recursive process is decomposing a system into elements. The first lifecycle model for systems engineering that we will consider in detail is the waterfall model. The waterfall model is a specified sequential process that follows a predetermined sequence. Waterfall is easily converted into schedules with deliverables, where the process flows downwards through all the stages that are required: concept, development, production, utilization, support, and retirement. By its nature, in waterfall, there is an embedded assumption that requirements are well understood and not likely to change during the execution of a project. The second approach is actually a class of methods: incremental and iterative methods. In use since the 1960s, details of incremental and iterative methods can be found in Larman and Basili's 2003 work, Iterative and Incremental Development, A Brief History. These methods are useful when requirements are unclear or uncertain at the start of a project. Candidate designs are developed and assessed with respect to stakeholder expectations. If acceptable, additional detail is developed. If not, the process iterates, evolving a design that better matches stakeholder needs. Incremental and iterative methods have proven to be successful for small, simpler systems or elements of a system due to their focus on flexibility and judicious risk-taking. A key concept to remember about incremental and iterative methods is that continuous or frequent feedback from stakeholders is incorporated into the approach, resulting in greater agility. The V model, often equated with systems engineering due to its broad application in the field, is a sequential method introduced in 1991 by Forsberg and Mose. V foregrounds the need to frequently validate designs with stakeholders, define verification plans during requirements development, and continuously perform risk assessment. In V, the design evolves over time from stakeholder requirements to the system concept, and finally, the elements of design. In the V representation, the system maturity progresses from left to right, but the V approach allows for iteration and recursion as necessary. Moving downward along the V focuses on system decomposition. Moving upward on the V, in other words, moving along the right-hand side, focuses on integration and testing of designs. When looking at the V representation, note the double-headed arrows linking the two sides of the V. These imply the potential for iteration as we learn from the integration and testing process. The next lesson of the Systems Engineering module will focus on the processes necessary to implement systems engineering practices.